All right, we are still in our force laws unit. These are the solutions to the orbits worksheet. So first thing, what shape do the orbits of all planets have? All planets move in elliptical orbits. With the sun at one focus. And as a note, something that may help you think about this. None of the planets travel in perfectly circular orbits, but they're really close. Circles are a special type of ellipse. But we need to say that all planets travel in elliptical orbits. All right. TV satellites have a geosynchronous orbit. That means they stay above the same part of the Earth every day. They do that so that this communication satellite can be predictably in the same place all of the time. Why doesn't the gravitational force change the speed of a satellite in circular orbit around the Earth? The gravitational force is perpendicular to the speed. It only turns the satellite. That's all that it does. And with this, that gravitational force is centripetal, and centripetal forces only turn. They don't speed up or slow down. So because that force is perpendicular to the velocity, it only turns. It doesn't speed it up. It doesn't slow it down. So, geosynchronous orbit at a fixed point above the Earth. What is necessary for this to happen? Are the satellites actually stationary? For this to happen, the period of the satellite must be 24 hours. One day, because in one day the Earth turns completely around and the satellite needs to turn with the Earth, so it's not stationary. The satellite turns with the Earth. That's what geosynchronous orbit is. How does the orbit of the Earth differ from the orbit of Neptune? So the Earth is closer to the Sun. It has a shorter orbital radius, or a smaller orbital radius. And Earth moves faster. There you go. How would our lives be different if Earth was more elliptical? So that more elliptical means we would be much closer to the Sun. At perihelion, or in the wintertime. Seasons would be affected by how close we are to the Sun. and not our angle. That's how seasons matter. Now it's whether we're pointed toward the sun or not pointed toward the sun. If we were on an elliptical orbit, seasons would be a lot different. When we were in the wintertime, much closer to the sun, it would actually get hotter because we were closer to the sun. That's problematic. Here we have a satellite in elliptical orbit with 7 points labeled. Which point has the highest velocity? That's point A. It is closest to the sun. Which one has the highest acceleration? Also point A, because the radius is smallest. Perigee is point A because it's closest. Apogee is point C because it's farthest away. Explain why astronauts in space feel weightless. They are in constant free fall. They still have weight, but they don't experience the weight. When you experience weight in everyday life, it's not because you are feeling gravity pull on you, it's because you're feeling something else push against you with Earth's gravity. When we feel weight, we feel the normal force. So when you feel weight, you feel the normal force acting on you. Because astronauts are in free fall, so objects in free fall don't have the normal force, so they don't feel any weight even though the weight is still there. It's called apparent or experienced gravity. Things that are in free fall have zero experienced gravity. And that's what astronauts are doing. They have a high sideways velocity, but they're constantly in free fall towards the Earth.